Welcome back, method students. The second chapter will be about sampling. When we do studies in social science, we want to know about populations. Populations are big groups of people, countries, households, objects we want to know about. If you, for example, want to do a study and you study the correlation between GDP and life expectancy, then your population will be all countries of the world. If you study the correlation between gender and salary in the country, then your population will be all Canadian adults. However, we don't use full populations to study from. We use samples. We do work with samples all the time. A sample is a fraction of the population I want to study. The sample is the fraction of the population I take my data from. In social science, we use samples for very good reasons. It's impossible to obtain information about the full population. It's too difficult. There's a lot of people, a lot of countries, a lot of households in the population. So it would be too time-consuming to collect data in the entire group. There's a census for that, but it's made by governments. It's not made by social science researchers. It would be too expensive as well. It would take years to study, for example, all Canadian citizens. And honestly, it might not be necessary. If you have a good sample to take your data from, if your sample is representative of all your population. If you want to know, for example, how many percent of Canadians are satisfied with the government during the pandemic, you cannot ask in a survey all Canadian citizens or all Canadian adults. We're millions. So, of course, we will select a sample of Canadian adults, and hopefully the data we get from our sample will be representative of the full Canadian population. So samples have to be representative of the population. It is their main quality. We want a sample to represent the population as well as possible. For example, if 40% of Americans are satisfied with Donald Trump, we have no clue how many percent are satisfied. We want to know. So we select a sample, we ask them, and if the sample says 40%, well, we hope it is representative of a 40% of the full population. But we never know. So samples must be representative. There are strategies for that. You'll learn them later on in this PowerPoint. If a sample is not representative, we say it is biased. And we want to avoid bias in science. So biased samples are not representative of the whole population because they systematically favor certain outcomes. They systematically overestimate results or underestimate results. So they're biased. One sampling method that we see sometimes in social science is called convenience sampling. And this is one example of a sampling method that is biased. Convenience sampling means you, as a researcher, select individuals who are the easiest to reach. So the researcher chooses the sample. Sometimes it's the only way to do things. You don't have a choice. You don't have access to what we call a random sample. So you kind of have to do a convenience sample. There are better ways to do things in this situation. But convenience samples are inevitably biased. They're not random. I will give you a very bad example of a convenience sampling. Very biased. Suppose that as a researcher, you want to know how many percent of Canadians are satisfied with the government response to the pandemic, the federal government. And you go on a Parliament Hill and you select your sample among members of a protest against the Liberals. Of course, all these people will be very unsatisfied. You chose them the wrong way. Maybe you have an agenda in your research, maybe you're dishonest as a researcher, or maybe you just didn't think. But such a sampling method here, such a convenient sampling method, will bring bias in your research. Suppose that to answer the exact same question, you go and select your sample at a Liberal rally where fans of Justin Trudeau are there, gathered. Of course, you will have very different results. Of course, people will be very satisfied with the government in your sample. But they're not representative of the whole population as your sample you would select on the Parliament Hill during a protest. So these are not good ways to select samples. Convenience sampling is not always as bad as the example I just gave you, but it's something social scientists try to avoid. Another sampling method that is biased is what we call voluntary response sampling. It's when subjects are free to answer. So you ask people in general, would you answer my survey? And those who want, those who are interested in answering your survey and filling out your survey questionnaire, will answer. So the sample here kind of chooses itself. Example, suppose that I am on campus. I put a table in the Agora with a sign there, survey about the cafeteria. Is the food good or not? And you're free to come and answer my survey. Chances are those who are not satisfied will come and answer my survey. Those who are very satisfied, or those who don't care or neutral, will just, pass and they will not come and see me. Online surveys are other examples of voluntary response sampling. Suppose that I send an online survey to all heritage students, asking them if they are happy with the Zoom lectures. And you're free to answer or not. Chances are those who are neutral or positive about Zoom lectures will just not answer, and those who are very unsatisfied and feel very strongly against that will answer the survey. So I will have negative outcomes overrepresented in my results. Another example of voluntary response. I'm sure you have seen these kind of popular surveys in your life. You go to a restaurant, there's a little card asking you to answer a survey about the food and the service. Maybe if you're satisfied or if you're neutral, you will just forget to do it. But if you're very, very unhappy about your food, you might fill out that form. So if you compile all these forms, you will have a very strong outcome of very negative opinions, maybe, that do not reflect the full population. Same thing for the right image is what you can find sometime in public bathrooms. So are you happy or not about the cleanliness? Most people who will answer that will hit the very poor quality icon because they were unhappy. So again here, those who are strongly against something or have strong feelings against or unhappy will answer the survey. So convenience sampling and voluntary response sampling are two sampling methods that are not random, that will probably bring bias in your research. What social science scholars want really is a random sampling method. Random is a key word here. Simple random sample is a kind of random sampling, is the simplest one. This is what we want. We want it to be random, so it's ideally unbiased. In a random sample, each subject of the population has an equal chance of being selected to be part of the sample. So this is why we have much more chances to have an unbiased sample when we use random sampling. We don't choose the sample doesn't choose itself. It is by people, subjects are chosen to be part of the sample by chance. There are two steps to follow when you do a random sampling, a SRS, a simple random sample. You have to know how many subjects you have in your population. You assign a number to each individual in your population. So it assumes here that you have a list of people from your population. This list, we call it a sampling frame. So you have a population, you know exactly how many subjects there are in your population, and you assign a number to each member of the population. Suppose that you have a very, very small population of 9 individuals, which is pretty unlikely, but let's say it exists. You will number them from 1 to 9, 1, 2, 3, 4, 5, etc. If you have a bigger population of 80 individuals, you will assign a number to each one of them, and the number given to each member of the population must have the same number of digits. So 80 has 2 digits. So my first subject in my population will be labeled 01, and then 03, and then 02, and then 03 to 80. If I have 1,000 individuals in my population, I will label them 0001, 0002 to 1000. So this is giving a numerical label to every individual, and every individual must have a number with an equal number of digits. Step number 2, then you use either a table of random digits or a randomizer online. I will show these to you. To select your sample. If you have a population of 1,000 subjects, you want to select 10 individuals in your sample, well, you will select only 10. This is an example of table of random digits. They all look basically the same. The column on the left, from 1 to 30, does not belong to the table. It's the line number 1, line number 2, etc. And you also see white spaces, blank spaces in rows and columns. They don't mean anything. It's just they're there because it's easier for your eyes to work with the table when there are empty spaces in it. So let's say I have a population of 90 subjects. I give every member of the population a number from 01 to 03, 02, 03 to 90, 90. So all members, each member of my population has a label. I will use this table of random digits to select a sample. Suppose that I want a sample of 3 subjects. They're numbered. My population has numbers from 01 to 90, 90. So I enter my table at line 1. First subject, 80, 80. So subject number 80 is the lucky one that's part of the sample. Next one, 94. Oh, this doesn't work because I have only 90 subjects in my population. So I have to skip 94. Next one, 25. 25 will be the second lucky person to be part of my sample. So I have so far 80 and 25. Next one, 25 again. We skip that. We go to the next one, 82. 82, subject number 82 will be the third one and last one in my sample. This is how we select a sample with a table of random digits. Now, of course, we live in the 21st century, so tables of random digits are still used by people, but we tend to use online randomizers like this one, or this is one of hundreds of examples that exist out there. You put, for example, how many subjects you have in your population, how many members you need in your sample, and you hit enter, and then the online randomizer will select your sample for you. There are many kinds of random sampling methods. Simple random, as we just saw, is not the only method of random sampling. There is another one I want you to know about, and it is called stratified random sampling. It's very easy. In a stratified random sample, the population is divided into subgroups. And these subgroups, we call them strata. This is why we call it stratified random sampling. And we take a random sample in each subgroup. Example, I have my methods class, your 28 students. I didn't count, but I think I have more males and females in my class. So suppose, I will exaggerate a little bit, suppose that I want to take a random sample of 3 students for any reason. And I kind of want both genders to be represented in my sample. And I know I have 18 males and 10 females. So I will separate my population into 2 groups, males and females, and I will take a random sampling in each of these groups. This way, I'm sure I will have males and females represented in my sample. Stratified random samples have to be proportional, and I will explain with an image what does it mean here. Here we are. Let's select a stratified random sample in a population composed of 3 strata, 3 subgroups. Suppose that you have a business. You have a very large number of customers. Here, your population is composed of 20 individuals in this image. But suppose you have a lot of customers. And your customers are, you know that 40% of them are Anglophones. They are the little black individuals in your second drawing here. Suppose that 30% of your population is composed of Francophones. They're the pale gray characters here. And 30% of your population is composed of Hispanics. So they're the yellow individuals here. So you know the composition of your population according to their native language, because somehow native language is important in your research about your business, and you want to know about any characteristic of your subjects based on their native language. So you know that 40% of them are Anglophones, 30% of them are Francophones, and 30% of them are Hispanics. You know the percentage. And you have to select a sample of 10 individuals. So 40% of 10 gives you 4. You will select 4 Anglophones. 30% of 10 gives you 3. So you will select 3 Francophones and 3 Hispanics. So in your sample, you have the exact same proportion of every native language than you had in your original population. Sometimes it's very important to have proportional representation of subjects.